Today we are speaking with Dr. Susan Whiting, Professor of Nutrition and Dietetics at the University of Saskatchewan in Canada. Dr. Whiting has spent over 30 years researching the effects of diet on bone health, and in the past 10 years has specialized in the vitamin D status of Canadians. Good morning, Dr. Whiting.
Good morning.
What made you start to specialize in vitamin D?
Well, I started, like many others, as a calcium researcher. So we were quite focused on the role of calcium in bone health, and I have to say that most of us took vitamin D for granted. We just assumed it was up there in the sky, coming down on everybody, not really realizing winter, for example, in Canada was such an impediment. We assumed that because we fortified our milk, at least for the last half century in Canada, that was all taken care of. So it really started about 2001 when some of the NIH symposia were being held and the cancer researchers were coming together with the nutrition community and realizing the important role of 25-hydroxyvitamin D and how diet and sun exposure was really key to those effects, and also realizing that vitamin D wasn't just a bone hormone but had all the paracrine, autocrine effects that we know about today.
Great. Do you think it's possible to be vitamin D sufficient to have over 40 nanograms per milliliter of 25-OHD by just eating real food?
Well, there's the problem, because we know that 40 nanograms per mil is an optimal amount, and we believe through all the research that's gone on in these last 10 years that many diseases could be prevented or the risk reduced by having levels over that. I'll just contrast that with the IOM level of 20 nanograms per mil. And even a person who eats like a Norwegian, that is someone who is eating a lot of fish, salmon, herring, more of a traditional diet, even 10% of Norwegians consuming that diet don't get over 20 nanograms per mil or 15 nanomoles per liter. So I'd say it's highly improbable anyone could get to 40 nanograms per mil just from diet alone. And especially an unfortified diet, yes.
Yes. And so that's what we were going to start to talk about, is how can we solve the vitamin D deficiency through food? And if someone, even a Norwegian who is eating those high vitamin D natural foods, if they're not even getting to 20 nanograms per milliliter, then how could we do it? Is there a way to fortify the food, and how does that work?
Well, right now in Canada and the United States, and we do have a mandatory fortification of milk, and there's some other foods that are fairly staple foods. People are getting, on average, from this fortified food supply, 200 international units, which we know doesn't bring you to even a satisfactory amount. So right now, with fortification, we're not there. But we want to talk about fortification in two ways. One, we need mandatory fortification in countries to bring people above a level that we know is effective. It even satisfies the critics, that such as the IOM. We need to sort of have a mandatory level in the diet, and then we need to have more foods that people can choose, and that will help raise their 25-hydroxy-D levels.
Okay, good. And do you know, has there been any other nutrient problems that were solved through fortification?
Well, we know that once we realize that a nutrient is missing, and often a nutrient is missing because of where people live. For example, iodine is missing in people who live in mountains. It's not in the soil. And so you can't tell those people to eat fish. They don't live anywhere near the ocean. So iodine is added to salt. It doesn't have to be, added just to salt. It could be found in other ways, but salt has been one of the common vehicles. And then that has solved the problem of iodine deficiency in many, many countries in the world. We also have the case right now in Canada and the United States of adding folic acid to our flour, and that has reduced neural tube defects by at least 50%. So there is precedent out there that fortification can work.
Great. Now, do you ever hear the argument about not fortifying food? Because why don't we just ask everyone to supplement at a maybe higher amount every day, and then we don't need to fortify the food?
Well, actually, even though we're talking about fortification, we're still going to need supplementation because fortification is a public health issue. And from a public health point of view, they're never going to fortify to levels that we think we need. That is to get us to 40 nanograms per mil. So really fortification at a population level is trying to get everybody over that minimal 20 nanograms per mil. And so that is definitely possible.
And those people that we're trying to get to 20 nanograms per mil, we can't just ask them to supplement?
Well, we can, but it's difficult because it's a bit of a cultural thing. If we look at different countries in the world right now, industrialized countries, in North America, we as a nation, Canada, United States, about 40 to 50% of the population takes a supplement, where in Europe maybe 10%. So it's the same people, the same food needs, but different approaches. So it's just to go back to the folic acid story. There was an attempt, and still in some countries, an attempt to have women in pregnancy and pre-pregnancy to take folic acid, but it's never 100%. So we need to have a baseline amount available in food, so someone doesn't have to get up in the morning and say, where am I going to get my, ABC nutrients? Many health-conscious people do that, and so they're the ones that are going to get the 40 nanograms per mil. But we need to get the rest of the population at least up over 20. So we need actually both strategies.
So that's a good question. It leads me to one of the things I was going to ask. Do you think in the U.S. and Canada, which is probably what you can speak to, that food fortification is actually working today? Is it getting our society to at least 20 nanograms per milliliter?
Well, it's not at a level that's enough to do that. To get us to 20 nanograms per mil, we need probably much more than even 400 or 600 IUs. And currently what both countries are providing is 200. So, but for example, one quick and easy way would be to double what we currently do. Let's, put twice as much in our milk. Let's put twice as much in our non-dairy beverages that people might drink instead of milk. Let's add more to cereals, and we could fairly easily get a much larger percentage of the population. So it's working, but it's not working as well as it could. Just for example, we looked at 25-hydroxy levels of Canadians who did not drink milk. And there's a clear difference between those two groups. So the milk is providing some vitamin D, but it's currently not enough.
Is there anything on the forefront of food fortification research? Are there any ideas? Is the doubling the best idea? Is there some other ideas to maybe add to more foods than milk and orange juice? What do you know about the current research?
Sure. There's a new initiative coming out of Europe called ODIN, O-D-I-N, and it's a strategy to fortify different foods according to the cultural needs of different countries. So if you think, Europe isn't one country. There's very many different societies, and perhaps in one country a certain food like fortification of eggs will work better. In another country it might be biofortification of mushrooms. And so they want to have a lot of different food-based strategies, and then have an idea of what country would take those up, and then they'll attempt to model what food fortification would look like and how it could at least bring populations over 20 nanograms per mil.
Wow, that sounds exciting. And what is your current research regarding foods and vitamin D?
Well, I'm continuing to work on the status of Canadians. We have a number of projects related to overweight and obesity in children and adults. And we're also looking at the different populations in Canada. With immigration and even our Indigenous people, we have we have found that European descendants with lighter skin can make it through our summers with pretty good vitamin D and then the fortification in the milk that they drink, whereas other people who are getting less sun exposure and not eating those fortified foods are really quite low. So we're looking and identifying the needs for policy, and also a group of us is looking at what's happening in Canada by not providing either supplements or fortification at a sufficient amount. What are the economic impacts of the health risks of being low in vitamin D?
And do you have any papers or studies that you would suggest people read to get more information on solving vitamin D deficiency through food fortification?
Well, my colleague Mona Calvo and I wrote a paper just a few years ago where we argue the need for mandatory fortification in order to bring most of the population up. And then we look at the issue of different fortified foods that are available. The only problem is because some of them are specialty foods, it can get quite expensive just to get 400 IU more in your diet. It could be $3 or $4. And I know your listeners would realize that one could take a supplement for 10 cents. So we're not just arguing economics, but we also want to make sure that foods that don't cost a lot can be fortified, and therefore that would be available to everybody.
Great. Well, thank you for your time today and your update on vitamin D in food.
Well, you're welcome. It's my pleasure to talk about vitamin D.